therefore I have to multiply this side by y to the third. So now my derivative is going to be actually y to the 6 minus 1 over 2y to the third. And I'll tell you guys why we do that in a little bit. Because once we plug it into the integral, it's actually much easier to evaluate that, especially with that squared. Okay, so just a little snippet there right when it comes to it. So now let's put it in our integral. So the length is from 1 to 2 of 1 plus all of this squared dy. Okay, and we're going to do the same thing we did last time. We're just going to slowly simplify as best we can. So on the bottom, we just square in this gives us 4y to the 6, right? And on the top, we're going to have to FOIL, right? Because it's y to the 6 minus 1 times another y to the 6 minus 1. So if you're wondering what that means. So again, just, that's just foiling. So I'm just going to skip that step. You guys can do that on your own if you like. So that gives us this. Okay. And now what we're going to do is put both of these fractions together, right? So it's technically over 1. So put them all together. Before y to the 6 plus all of this. Keep forgetting my dy. Okay. All right, so that gives you 4 plus 2 gives you positive 2y. And again, believe it or not, this actually factors kind of nicely. So again, I'll leave it up to you guys to factor it. So once you factor it, you get y to the 6 plus 1, believe it or not, squared. All right, notice now when we take the square root, a lot of stuff cancels. And the good thing is this will always be positive, right? Because there's never be negative, right? So something squared to the 6 powers, again, positive. And if you add 1, again, it's going to be positive. So we don't have to take the absolute value this time. So it's just going to be y to the 6 plus 1 over. And again, taking the square root of here gives you 2y to the third power. And there we go. Okay. And again, right, this may look horrible, but I'm going to break them up. You always want to break stuff up, make it easier. So this, so if I look at this simplifies just to y to the third over 2. And on this side, I have exactly that. Right? So it's technically y to negative 3 over 2. And again, the reason why I do this is because for my sake, it's just easier for me to remember that the power is negative to do that. That's all I'm doing, right? I'm just bringing this to the top. Just for my sake, for integration, is for me, it was easier to do that. So now let's take an integral of this. So this is going to be y to the 4th over 8, right? Because 2 times 4 is 8. Take the integral of this. So be y to the negative 2 power over, what's it, 4? Add 1. Yep, so negative 4. Yeah, so minus 4. Yep. And evaluate this at 1 and 2. Okay, and same thing. So run out of space a little bit here. So just get a little sheet of paper. Right, so we have 2 to the 4th over 8 minus 2 to the negative 2 power over 4 minus the 1. So it's technically 1/8 minus 1/4. There. Not too bad, right, when it comes to it. So let's see. This is going to be the bottom, right? So negative 2 power, so this is going to be 4 times 4 is 16 on the bottom. So 2 to the 4th divided by 8. Let's see what we get there. So I think 2 to the 4th is 16, but I'm not really sure. Yep, 16 divided by 8 gives you 2. Minus, again, this is going to be 16 on the bottom. Again, right, if I just break this down, 2 squared is 4 times 4 gives you that. And over here, putting these together, this is going to be 2/8. So it's negative 1/8. Keep going. This is 32 over 16. And I'll also do this in 16 as well, make it easier. This is negative 2 over 16. And then finally we can subtract. This will be plus plus, so that's nice. So this will be 32 minus 1 is 31, plus another 1 is going to be 33. So this is 33 over 16 as our answer. So a little bit over 2. So again, hopefully it's just lengthy, and notice, we don't take really hard integrals, right? It's just slowly simplifying that square root to make it something much easier to deal with when it comes to it. Okay. All right, so let's try one more example so you guys again a little bit more practice to deal with this kind of stuff. So find the arc length of the curve x squared is equal to y minus 4 to the 3rd power from the points 1, 5 and 8, 8. Now in this situation, they actually give you a choice of what you want to do. You can either solve for y or solve for x, because they gave you the points in either case, right? So remember, this is x1, y1, x2, y2, right? So we can integrate with respect to x, and we go from 1 to 8, or we either with respect to y, we can go from 5 to 8, right? It really doesn't matter at this point. You will get the same answer when it comes to it. So again, since we already have x squared equals it, I'm just going to solve for x. So if I just take this square root of both sides, we now get this. Right, in its exponential form. So therefore, right, since I solve for x, we're going to be using the 1 and the 8. Oh, I'm sorry. No. We're using the y's, not this one. The 5 to the 8s. If we did the other way, we would do 1 to 8. So if you solve for y here, so if you take the cube root and then add 4, which could be probably easier sometimes, you would go from 1 to 8. The way I'm going to do it here, because I solve for x, I'm going to go from 5 to 8, because we're integrating with respect to y. So we have to find the y values there itself. Okay? So now that I'm thinking about it, it might be actually easier to go the other way, but I started this way, so we can go from here when it comes to it. All right, so next up is take the derivative. So same thing, right, chain rule. So derivative of the outside is this, times the derivative of the inside. So now this is a y. So minus 1 gives you 1/2. And the derivative of the inside is just 1, which is perfect, so that's it. That's a nice little derivative. And then we can just go straight into our portion. So let's go from 5 to 8 of all of this. And notice this is a kind of nice one because stuff cancels pretty nicely, right? Oh, I forgot my fraction. 3/2 there. So simplifying this a little bit. So squaring that gives you 9 on the top and 4 on the bottom of just y minus 4, right? Because those cancel away. So not too bad this time, right, when it comes to it. Okay. So distributing this 9 and just multiplying by 4, right, because again, notice the same pattern there. So we'll have integral from 5 to 8 of 4 plus 9y minus 36 all over 4. Simplifying this a little bit more. This is 9y minus 32 over 4. And maybe we're, okay, this one didn't work out, right? We can't just factor out, but it's actually not that bad of an integral, right? So we'll just use substitution. Let u equal 9y minus 32 over 4. So du ends up being just 9 over 4 dy. So flipping this around, so 4 over 9 du is equal to 1 dy. So this is the integral of u to the 1/2 power, or just the square root of u. So this is being adding 1, so u to the 3/2, so 2/3. Right, evaluated from 5 to 8. And then we plug in back what u was to begin with, right? Oh, don't forget, so this is also, forgot, this is 4 nights on the outside. All right, so now, right, because this one goes here, so this is technically right there as well. All right, so let's plug this in. So we have 4 times 2 is 8, 9 times 3 is 27 on the outside, and then we plug in what u is, and u is all of this, all raised to the 3/2 power, and it's going to be evaluated at 5 to 8. Wasn't too bad this time, right? But, still pretty lengthy to begin with. So what happens when we plug in 8? Let's see. So 9 times 8, I believe, is 72. Minus 32 gives you 40. Divided by 10, or sorry, divided by 4 gives you 10. So this is going to end up being 8 over 27. 40 minus 32 is 8. Divided by 4 gives you 2. So minus 8 over 27 times 2 raised to the 3/2 power. Which could be a horrible mess, right, when it comes to it. But let's see what we get. Let's see. So 10 raised to the 3/2 power times 8 divided by 27 gives us approximately 9.36. It's like 9-ish. And the other way, so 2 raised to the 3/2 power times 8 divided by 27 gives us this. And then we just subtract them. So what does that give us? So 9.369 minus 0.838 gives us approximately that. And again, if this was negative, we'll make it positive, because when we take the square root, right, there's a certain criteria, so 9y must be greater than 32, or exactly 32 above, in order to make this work. So if it, end up being negative, we'll just make it, we're done the absolute value. So technically, we want the absolute value of this portion, because we had some criteria there. And y had to be strictly greater than some values to make this work. Yeah. And there we go. There is our answer there.